Can people see that?
Looks great.
Okay. Sorry, I'm a few slides ahead. The first question that you might ask is, why are we doing this? And so I want to tell a little bit of history about how we got to the decision to build this toolchain that allows us to create cross-plane controllers using Terraform providers. So the options we considered when we first decided we needed to move a lot faster on getting good coverage of all the major cloud provider APIs. One was use the APIs we've been talking about today, which were in a much earlier state when we started talking about this, like ACK and ASO and config connector. Use those as the API. And Brian Grant recently asked this question as a GitHub issue, and you can see Nick's answer is essentially that we felt that it didn't fit the XRM model that we were trying to build with Crossplane, when we would then have to go and kind of manage a different set of resources that work differently. It actually would create a lot of complexity where we would need to write these kind of meta controllers. It would be different for every cloud provider, and you're going to see a theme here, which is things being different enough between each provider that we weren't really able to get very good leverage, and so it was going to be a lot of work to build distinct code generation approaches for each provider. So another option is, you have OpenAPI. In the case of Azure, AWS has their schema format. Google offers gRPC descriptions of APIs. But similar kind of problem here of, there's also things outside of the API, like Matt was talking about, like how are authentication handled? How do we deal with errors? And so still left a lot of work outside of what we could easily generate. Another option was tools like CloudFormation, Deployment Manager, Azure Resource Manager, which once again, lots of differences between different tools, and also just some gross user experience issues, like do we treat an entire composition as a CloudFormation stack? What if it's just a single resource? Is that a CloudFormation stack? And we didn't want to kind of ruin people's experience using CloudFormation by exploding it with hundreds of resources, each being in their own little stack. So what the conclusion we came to is that Terraform was going to allow us to build on our cross-plane resource model, the XRM you've heard people talk about, and gives us one consistent API that we need to target for code generation. And on those topics of undocumented API semantics and API behavior, we just know there's a huge amount of huge assets that the community has built up of all this lore in the form of code that is inside of these providers. And so we saw code generation as an opportunity to unlock all of that and use it to get more coverage. But kind of really the point of this talk is that there is a long tail of providers companies that have written Terraform providers for their internal systems, or other public companies, bare metal providers, things like that have written Terraform providers or to Bassam's example in Slack, there's the Domino's Pizza Terraform provider. So it's just this huge corpus of providers that we can generate for and cover, unexpected and sometimes even APIs that might not be out there in the public. And so getting closer to the demo, this is to give you an idea of how we use Terraform, like the architecture of Terraform that enables us to take this approach. When you run the Terraform CLI and you give it a manifest that specifies a provider, under the hood, what it's doing is going and downloading a binary that is a program that implements the provider, and the program has a little bit of negotiation that it does with the process that forked it off to communicate version information and where its gRPC services, and then everything else happens over a local host socket over gRPC. Sounds a little bit more promising than it is, because inside of the gRPC messages, it's actually very custom to Terraform and to HCL. So there's actually a lot of work that still has to be done in order to talk to the provider, in order to get it to do the CRUD operations that we know are back behind this API line. So this diagram is kind of showing you, you have the Terraform CLI, and we built something called Terraform Provider Runtime that knows how to use that set of APIs, the same set of APIs that Terraform CLI uses to unlock all this functionality in Terraform. So the important APIs are you can get the schema of resources. So that gives you the schema of all resources the provider knows about in a format that is pretty special to Terraform. Called config schema /CTY. It's basically a representation of HCL. So so as we build out this project, we need to constantly be mapping between what does something look like in Kubernetes and what would it look like in HCL. And that's a lot of the complexity of the code generation is mapping between those two very different structures. Configure method, that's where you're giving the provider its credentials and region, in the case of AWS. Read resource, which what it sounds like, it's reading the resource from the cloud provider. And then everything else, create, update, and delete is all through apply resource change. And the truth table to think about is you have previous state and desired state. And if previous state is null and desired state is not null, you want to create something. If they both are not null, you're updating something. And if previous is not null and desired is null, you're deleting it. And so that's basically how we interact with the apply resource change method to carry out these or fulfill the CRUD interface that you see in a Crossplane external client. So I'm going to switch over into demo mode to give you a better idea what this looks like. So we'll look at this resource here. This is an IAM user. And what I'm going to show you is completely code generated. So at the moment, we've got 347 resources. I haven't tested all these. I'm sure a lot of them don't work. And there's actually going to be a lot more once we deal with some of the complexity that arises from resources that are more deeply nested, more complex resources. So what I have so far are more the simple resources. So IAM user is a pretty simple resource and a useful one potentially. So that's what I'm showing off here. So you can see that we've generated the Go code and used controller gen to generate the CRDs. And decopy and use AngryJet to generate the Crossplane method set. And let me just go ahead and apply this. And we'll start looking at a little bit more code. Okay, so so inside of Terraform Runtime, we have essentially a generic code that wires up that generic controller in different instances of the generic controller to handle each resource type. And so there's three areas, three classes of code that we need to generate in order to handle a resource. And that'll become more clear as we step into this a little bit further. So now it's not going to read this because it doesn't exist yet. So I'm just going to jump through here. Okay, so here we are in create. Now, so the first piece of generated code is the encoding. And so this is how we go from the Go type that represents a CRD to the encoding that Terraform understands. This is not generated code. This is the plugin library code. And here we are jumping into the injected generated code. You can see, we tried to make this somewhat readable by breaking everything out into a tree of functions. But essentially what's happening here is the code generator used the schema description to figure out how to translate between the two. There's kind of a tree-based structure of fields that represents the CRDs, and then each field has a set of callbacks that can generate all these pieces of generated code you're looking at here. So one thing to note here is that we use our external name annotation to set the ID field. That's basically Terraform's version of external name is ID. So we always exclude ID. We kind of filter that out of the code gen and manually set it to external name here. Okay, I'll start jumping through this a little bit faster now. So now we've got the CTY value that Terraform understands. We're going to try to read it, and that's going to fail. And now, okay, now we're actually trying to create it. Sorry, I jumped through that kind of fast. There's an important part in the middle I'll show you next time around. Okay, so here is the other 2 of 3 pieces of code generation. This is decoder. It's just the opposite of the encoder. So we're going from Terraform representation to the Crossplane representation. You can see this code looks really similar. It's just kind of the same thing. Well, it's generated very differently and it works very differently, but it's effectively the same thing in reverse. So we're kind of dealing with the different nesting structures and going back to Crossplane shape. And you can see here we're setting the external name annotation. We can take a peek at this resource we're building up here. And you can see that, oh yeah, the debugger doesn't like that. I'll show you in Kubernetes in a moment. But you can see status is being populated here. So this is the ARN and unique ID. We got that from Terraform. Okay, and now, oh, that was what I want to show. We'll have another chance in a moment. Okay. Now I think we're just doing another read. Basically, I'm trying to fast forward until I get the pause button when we're in a long wait. There we are. Okay, so now I've got another version of this. Same object, but you can see I have learned what team Clamps is on. He's on the Robot Mafia team, and so I want to update the tags. Okay, so here we are in observe. What's going to happen here is we're going to read the resource through Terraform. Just decoded it. Okay, here's the merge I wanted to show. And this is the third category of generated code. So here we're actually comparing the 2 CRDs and figure out if something changed. Based on this, we're going to know that we need to call update next. This is also where we would handle, setting late initialized spec fields if we know that it's something the provider can specify if it's computed value, and also where we would set the status field, like when you saw the ARN in the status, it got set in this merge function. So I'm going to bounce out of here just so we can finish up the demo. Oops, let's get us to a pause button. So it's going to be calling apply resource change again to do the update. Okay, so now we should be able to say, oops. Okay, user, not users. Okay, so there's a user. You can see it was created. I should have tried to get it before I created it, so you could see I wasn't. There was nothing on my sleeves. We created it first, and then you can see the second key here in tags was added by that subsequent update. And now we will. Let me. I'm remembering these CRD resource names. Okay, so yeah, so we can see the status fields here. And now I'm going to delete it. hang while I hit the play button a bunch of times. I'm actually going to just start clearing checkpoints so this doesn't take so long. This is really good TV, isn't it? Okay. Now the delete actually takes a little bit. I think it might be kind of a slow API call. It's slower to delete than it is to create or update. You can see here, this is debug output from Terraform that it's calling the Amazon delete API. I'll come back here in a minute to show that it actually deleted. But let's see here. Is there anything else interesting in these slides? I think I just went through all this in a more low-level fashion by showing in the debugger. This is showing the general idea of the code generation pipeline, similar to what other people have talked about today. Oh yes, let's talk about where we're going to go next. At the current point, this is very experimental. In Q1, we're hoping to get this to alpha, where people could actually try to manage some resources with it. Right now, I would not trust it, but it's going to get there pretty fast. Full coverage means cover all the different shapes of Terraform resources. We need documentation. The code is a huge mess because it's prototype code. As I've been spelunking through this Crossplane Terraform interaction, figuring things out, we need better events or logging for Terraform errors, figure out a better user experience for that. And then I want to put this out there and get feedback from people. And then we currently aren't doing anything for secrets, so we need to design a way to layer on secrets independently of the resources. The current secret implementation is like kind of in the code, and we aren't going to be able to code generate that. So similar idea with cross-resource reference design. So we're talking about, I'm going to put out some design docs for ways to represent what to do with secrets and what to do with references independent of the resources.